In this video, we'll talk about the mean or the classification of the mean, that is arithmetic mean, geometric mean, and the harmonic mean. So let's start from the arithmetic mean. The average of a set of numerical values calculated by adding them together and dividing by the number of terms in the set is arithmetic mean. So say we have a raw data that is x1, x2, x3, x4 and till xn. According to the definition, we have to find out the summation of the variable values of the data first, and then we have to divide this summation by the number of terms in the set, that is n here. So first the summation of the data is summation of xi from 1 to n. So here the am, that is arithmetic mean, is equals to the summation of xi I from 1 to n divided by total number of terms in the set, that is n. So here this is the formula of arithmetic mean. So let's take an example, a simple example, that is we have a raw data that is 4, 5, 6, 7, 8. So how can you find out the arithmetic mean of this data? According to the formula, I have to find out the summation of this data, that is 4 plus 5 plus 6 plus 7 plus 8, which is equals to 30. So the arithmetic mean am should be is equals to 30 divided by total number of observations, that is 5 in this data. So the arithmetic mean is equals to 30 divided by 5, which is 6. So this is the arithmetic mean of this raw data or the individual data. So here we have a discrete series and we have to find out the arithmetic mean of this discrete series. So for finding out the arithmetic mean of a discrete series, we have a formula, that is arithmetic mean is equals to summation fi xi divided by n. Here fi it means the individual frequency and xi means the individual value. And the summation of fi xi means the summation of the product of individual values with their corresponding frequency. And n means the total number of observations, that is summation of fi. So let's find out the summation of fi xi from a frequency distribution table. And here we have a frequency distribution table, and we already know how to construct a frequency distribution tabular form. So here we have the values and their corresponding frequency, and it's too easy to find out the multiplication of the values and their corresponding frequency. So here the value is 12 and its corresponding frequency is 3. So the multiplication of the value and its corresponding frequency should be 12 into 3, that is 36, then 15 into 6, that is 90, 20 into 8, that is 160, and here 161, and it is 150. We can use a calculator to find out the summation of these multiplicative outcomes, and that is 36 plus 90 plus 160 plus 161 plus 150, and this is equals to 597. That means the summation of fi xi is equals to 597, and the total number of observations here 3 plus 6 plus 8 plus 7 plus 6 is equals to summation of fi, that is 30. So we just have to put the values into the formula. So here the summation of fi xi is equals to 597 and the total number of observations is 30, and we can use a calculator to solve this simple problem. 597 divided by 30 is equals to 19.9. So the arithmetic mean for this discrete series is 19.9. There is another method to decrease or reduce the calculating difficulties, and this method is known as shortcut method, and we are using the direct method. Here we are using the direct method, and there's another method that is known as shortcut method. In some books, the shortcut method is also known as, also written as coding method, and for the discrete series is the deviation method, and for a continuous or grouped series it's known as step deviation method. So let's talk about the deviation method or the shortcut method for the discrete series. Here we have the same discrete series, and we're gonna find out the arithmetic mean by shortcut or deviation method for this discrete series. And to find out the arithmetic mean by shortcut method, the formula is a plus summation of fi di divided by n. Here di means the deviation of individuals, difference of a value and the assumed mean. So how can we find out the assumed mean? The assumed mean should be the middlemost value of the observations. Here we have 5 observations, so we can find out the middlemost value by this formula, n by 2. So here n means the number of observations. Here we have 5 number of observations, that is 5 by 2, and we will get a number that is 2.5. If the result is a fraction, then the next integer number will be the assumed mean. Here the third number will be the assumed mean, and the third number is 20. So the A for assumed mean is equals to 20, and deviation for individuals can be measured by finding out the difference between of an individual value and assumed mean. So here di is equals to xi minus a. It's good to show the formula in the heading of the frequency distribution table. Here the individual value is 12 and the assumed mean is 20. So 12 minus 20 is equals to minus 8. Doing this process continuously, we'll get the results, that is minus 5, 0, 3 and 5. As same of the direct method, here we have to find out the deviation of individual with its correspondent frequency. So here the multiplicative result of 3 and minus 8 should be minus 24, and it's minus 30, and here 8 into 0, which is 0, and 7 into 3 is equals to 21, and 6 into 5 is equals to 30. So in the formula we can see we need the summation of multiplicative result of a individual deviation with its corresponding frequency. So here summation of fi di can be measured, and it should be minus 3. So the summation of fi di is equals to minus 3, and total number of observations is here 30, as you can see in the earlier problem. Here let's identify the terms, that is di means the deviation of individual and n is the total frequency. So by putting the values in the formula, we'll get the arithmetic mean, that is am is equals to 20 plus minus 3 divided by n is equals to 30. So the result will be 20 plus minus 3 divided by 30, and that is 19.9. That means the result of the arithmetic mean for a discrete series will be same for all the methods. So let's talk about the grouped data, that means the continuous series. Here we have a grouped data or continuous series, and as the discrete series for a grouped data, we also have 2 methods, that is direct method and shortcut method, and here the shortcut method also known as step deviation method. So we'll find out the arithmetic mean by both of those methods, and let's start from the direct method. So the formula for the discrete series and the continuous series is equals, that is summation of fi xi divided by n. Here xi doesn't means a unique value, xi means the middle value, that means the class mark of a class. So let's construct a frequency distribution for this grouped data, that is the first class is 0 to 10 and second is 10 to 20, 40 to 50, and the corresponding frequencies are 3, 6, 8, 6, 7. And we all know how to find out the mid value, that is the summation of upper limit of the class and the lower limit of the class, and then divided by 2, that is 10 plus 0 divided by 2 is equals to 5, and by doing this process continuously we'll get the result, that is 15, 25, 35, and here it will be 45. And the multiplicative result of a middle value with its correspondent frequency, here 3 into 5 is equals to 15, 6 into 15 we can find out it by using the calculator. 6 into 15 is equals to 90, and 25 into 8 is equals to 200, and 35 into 6 is equals to 210, and 45 into 7 is equals to 315. So the summation of fy xi should be 315 plus 210 plus 200 plus 90 plus 15, that is 830. And the summation of frequency, that means the total frequency, is equals to 30. So we have to do nothing but put these values in the formula, and we'll get the result of arithmetic mean for this grouped data automatically. So here the arithmetic mean for this group data is equals to 830 divided by 30, that is equals to 830 divided by 30, 27.66. So the arithmetic mean for this grouped data is 27.66. Now we'll discuss about the shortcut method, that is step deviation method or coding method for this grouped data. We have a formula for shortcut method for the grouped data, and that is arithmetic mean is equals to a plus summation of fy di divided by n into c. We already know that di means the individual deviation and a is the assumed mean, and here extra c is the class interval. So let's find out the value of individual deviation, and the formula for finding out this: x minus a divided by c. Here a is the assumed mean and c for class interval, as we know, and by using this formula we'll get the deviation for individual, and finally we have to find out the multiplicative result of individual deviation with its corresponding frequency, that is difi, and we also called it as fi di. Here the mid values are 15, 25, sorry, it will be 15, it's 05, and here 25, 35 and 45. So here the assumed mean should be 25. As we know, the assumed mean is the middlemost value of the observations. So here we have 5 value in our observation, and the middle value is 25. So the assumed mean a is 25, and we have to find out the deviation by using this assumed mean. So if we try to find out the deviation for this data, the deviation will be 5 minus 25 divided by the class interval, that is 10. That means 5 minus 25 divided by 10 is equals to 2 minus 2, and here the class interval is equals to 10. And by doing this process continuously we will get the results. That's minus 1, 0, 1 and 2, and finally we have to multiplicate this individual deviation with their corresponding frequency, and the result will be 3 into minus 2, that is minus 6, 6 into minus 1, minus 6, 0, 6 and 14. So the summation of this multiplicative result should be 8, and the total frequency is 30 here. We have to do nothing but put this value in the formula, and we will get the result, that is arithmetic mean of this grouped data. So here the arithmetic mean is equals to a, that is 25, plus summation of fi di, we got it as 8, and total frequency is 30 into the class interval, that is 10. So we are using a calculator for solve this problem. That is 25 plus 8 divided by 30 into 10, and the result will be 27.66. As you can see, we got the same result for the direct method of arithmetic mean for grouped data. That means we will get the same result for arithmetic mean of grouped or discrete data for any kind of method to solve.